In this video, we'll be looking at lesson 0.4, function families. So we're going to kind of break down these function families into some basic introductory ones, and we'll talk about 5 different ones today. We'll talk about some characteristics they have. We'll talk about how their graphs look, and we'll also talk about what their equations look like. So this might be a couple pages of notes, and this might be a little bit of a longer section. So if you need to take a break during this, pause and then come back to it later. That's fine. But do try to get through this whole notes section before showing up to class tomorrow. So our essential question will be, what are characteristics, graphs, and equations of the different function families? What are characteristics, graphs, and equations of the different function families? So the first one we'll talk about is a linear family, the linear function family. So this is linear. And the linear is a line where the x has no exponents. So the graph is a line, and our equation is an x has no exponent. Some characteristics: no max, no min, and we'll look at 3 different types. This is an increasing one. We'll look at an increasing graph will just be going from left to right. It's going in an upward direction. So when I draw it from left to right, or my pencil travels along it from left to right, I go in an upward direction. So that's increasing. And when we talk about the equations, the x part is always positive. So y equals x, y equals 3x minus 4, y equals 5 halves x plus 7. So that x piece is always positive. Positive x, positive 3x, positive 5 halves x. Now when we're looking at decreasing, now we're going down when I travel left to right. And this one, that x piece, since we're going down, it'll be a negative x. So examples would be y equals negative x, y equals negative 2x plus 8, or y equals negative 3/4 x minus 9. On all of these, that x part is our negative. And our last one is our constant. And this one's unique because the x just kind of goes away. So you just have y equaling a constant number, or just a regular number by itself. And these are flat. So when I have them, it's a flat line, like so. And our equations are y equaling just some number. Y equals 1, y equals -7, or y could even equal a fraction, -4/9. So anytime you have y equaling just a number, that's going to be our constant function. Oh, one other thing I want to add to this is it's no max, no min, and lines are continuous. Okay, that's our linear function. Next, we'll have our absolute value family. And this is V-shaped. And the equation we'll have has the absolute value bars. So here's a example where we have a maximum, so I'll draw it like so. Let me for some equations. And it's going to be a maximum, and it's V-shaped, but since it's a maximum, it's going to be an upside down V, like so. And some example of some equations are y equals negative absolute value of x, y equals negative absolute value of 3x plus 4, or say y equals negative 2 times the absolute value of x minus 7. And then we have the other side where I flip my v, and that will have a minimum, an absolute value with a minimum. So I'll have a lowest point on this graph. That'll look something like this, where my v is now pointing in the right direction, creating a minimum point. That's a minimum, that's a maximum. So my minimum point, and now I don't have those negatives out front. So I just have y equals the absolute value of x, y equals the absolute value of 7x minus 100, or y equals absolute value of 3x plus 4. All those are examples. Next, we'll look at our quadratic. And the quadratic is U-shaped, and it always has an exponent of 2. So if you see that exponent and the highest exponent is 2, then you know you're dealing with a quadratic. So we'll have a minimum quadratic. Let's do the same order. So we'll do maximum quadratic. It's going to look something like this. So maximum quadratic will have a maximum value. So that means it's going to be shaped like a U. So it's got some curve to it. And there will be a maximum point at the top of it. Some example equations would be um, y equals x squared, y equals x squared plus 4x plus 7. We might even see y equals, in parentheses, x plus 3 squared minus 8. So anytime we see that exponent of 2, we know quadratic. Exponent of 2, quadratic. Exponent of 2, quadratic. So let's look at a minimum. Oh, maximum. Shucks. All these are negative. So let's make some space for that negative. So when it's a maximum, we have a negative out in front of our x. And the minimum will be the opposite, no negative. So we'll have a lowest point, a minimum point, and then it's U-shaped coming up from that point. And then I have equations where all my x values are positive. So I could have y equals positive x squared, or y equals x squared minus 7x plus 8. So I need that x squared part to be positive. Or I'm going to have y equals x plus 3 squared minus 10. So as long as that x part, the x squared part, x squared, is positive, we have a quadratic with a minimum. But most importantly, what we want to really remember is that a quadratic always has an exponent of 2. So look, if you see that 2 is your exponent, the highest exponent is 2, you know you're dealing with a quadratic. The next thing I want to do is look at an exponential function. So some qualities of this: it is ramp shaped, kind of looks like a quarter pipe, and x is in the exponent. So you'll have that variable x sitting in the exponent. So we have two kinds we'll kind of focus on. We'll have growth. Oop, just sneeze. Sorry about that. So we'll have some growth exponential. So that's where the graph is increasing from left to right. So it'll look something like this. And it has that kind of like quarter pipe or ramp shaped, like so. And on these, we'll have example equations where we have a number greater than 1 raised to the x. So 2 to the x, 5 to the x. And it can be a fraction, but fractions can be greater than 1. So you could have y equals some improper fraction raised to the x. Most important is exponential x is in the exponent. So when you have an exponential function, your x is in the exponent. X in the exponent, exponential. X in the exponent, exponential. The next one we'll look at is decay. And in this one, it's the same kind of quarter pipe, but instead of growing, so from left to right, increasing, from left to right, we will be decreasing. But it'll look very similar. So now I have the other side of, I guess, my half pipe. So this quarter pipe. But now I'm decreasing from left to right. And for this value this base value is now less than 1. So any number between 0 and 1, we're not going to look at negatives today, but we might look at them in the future. But we're just looking at positive values that are less than 1. So they're all going to be fractions or a decimal. So you could have y equals 1/2 raised to the x. 1/2 is less than 1. You could have y equals 0.3 raised to the x. That's less than 1. Or you could have y equals 2/3 raised to the x. So anything where it's less than 1 but positive will look like that. And that's our exponential functions. Our last one will be a piecewise linear function. So this is a function that's broken up into multiple pieces that you can kind of, pretty much clearly see when looking at the picture. And then the equation itself will have multiple pieces to the equation. So let's say I'm looking at this guy. So I would have maybe I could have a line going up, and then maybe it flattens out, and then maybe it goes down like so. So you can see that it has multiple pieces. There's this piece that's increasing, this piece that's constant, and then there's this piece that's decreasing. And doesn't always have to be represented by increasing, constant, decreasing. It could just be two pieces, increasing, then decreasing. Or it could be increasing, constant, increasing. So as long as you see multiple pieces and it's not a clear V shape, then you know that it's going to be a piecewise. And the equation looks kind of complicated, but what we do is you'll see something like so. And then inside the squiggly bracket will be the three pieces that make up the equation. So I'll have my increasing, so say y equals 3x plus 1. Then I'll have my constant piece, and that would be something like 4. And then I have my decreasing piece, which is maybe like negative 5x plus 8. So now I can see my equation has pieces, multiple pieces to it, just like my graph has multiple pieces to it. And those are our function families. So thank you for watching this video, and I hope you have a great rest of your day.